so my name is Richard Seroter. I'm glad to be here. We're going to talk about open source messaging options and why you should care about them, hopefully, not just that they're cool and interesting, but why they may introduce some new ideas for you. So I switched jobs recently. I work for Pivotal Software. We build a platform as a service product that runs on Azure, runs on premises. Last week, Microsoft and Ford gave us $250 million to keep building it, so pretty excited about that. In my other time, I'm Microsoft MVP for a few years, written a couple of books. I write for InfoQ. I do some Pluralsight courses and keep myself busy. So glad to talk about some of these technologies. I know I'm running a MacBook. I'm talking open source. Who the hell am I anymore? Everything's changing. But we'll have fun talking about things changing in integration. So the integration space is changing. Not crazy fast, but we've seen some great presentations over the course of the last couple of days talking about some of these things that are going on, different volumes of data, different sorts of data sources. And I went looking for a good presentation that talked about all these trends and tried to figure out, is there something that summarizes all these integration trends, something I can use as a resource? And I found a frankly remarkable presentation. It was mine. Nothing? Look at you people. I'm not actually that arrogant. But it was a good presentation that I put together a couple years ago that talked about microservices, talked about Internet of Things, talked about DevOps, containers, all these sorts of things. And so all these things are happening and they're changing the face of integration. So what can be tricky is you can feel a little bit like you fall behind. Even if you're just tracking Azure, I mean, what are we up to now? 150 different Microsoft tools for integration? It's hard alone to keep up with that. Are you also keeping up with what's going on in the industry? So it can be tricky. You can feel like you're not keeping up with what's going on there. What I hope to do is just show you a few of those options and get a sense of those patterns that are out there that are being used by some of the most popular tools in the industry right now, and that maybe some of those patterns can apply to what you're doing on the Microsoft stack, or maybe you're going to bump into some of these. They're going to be things that run side by side, or they're going to be things that you use both technologies, or someone wants to bring it in, you want to be able to talk intelligently about it. So I just want to kind of show some of those key things. So I'm going to do 3 things with you. I'm going to talk about some of those modern integration criteria, touching on some of the things Dan mentioned as well. We're going to review some of the popular open source tools. I'll do some demos. We'll see how well they go. And I'll do a light comparison to some of the things in the Microsoft portfolio, just so you can have a sense of how do these things map from one to the other, how can I get my frame of reference right. So first off, let's look at the modern integration criteria. And I say this is modern, but I mean, let's be honest. Most integration is still weird banking systems that ship out CSV files that you're FTPing around. So I understand that many of these things I'm showing you are still not what everyone gets to do, but there's a clear trend towards these sort of things. So the patterns have stayed the same, right? It doesn't matter. Some of these are timeless when you talk about pub sub and queuing and things like that. That's not going anywhere different. But the difference is I don't need big complex systems to do this as much anymore. I can do this with a much more microservices integration approach. So nowadays, when you're talking about integration service, you have to be talking high availability and resilience. There are no 9-to-5 apps anymore. We're all online at whatever time, in whatever country, accessing systems. These integration solutions which tie them together can't be down for maintenance on a Saturday, because Saturday could be just as important as Friday afternoon or Tuesday. These things have to be available. They have to be able to handle bursts that might take a node down, and everything else should be just up and running. That's what systems are doing nowadays, is these are heartbeat systems, just like BizTalk is, just like others, but now it's not just enterprise integration. I'm using Service Bus 360. I'm connecting things all over the place. So my integration bus has to be online all the time. Significant throughput. We're hearing these silly numbers from Clemens and team, which is awesome. But I mean, I can't even get my head around 2.7 trillion, whatever it is, messages a week. That's nuts. But you're talking about a throughput here that is intense. And it's also low latency. It's not just volume. It's am I processing this stuff quickly? And as you're doing machine learning, as you're doing these things, my previous job, I was running product for CenturyLink's cloud, and we use these tools to run hundreds of millions of telemetry points, and I can't use a traditional ESB for that. It won't work. So it's a different way of thinking about this sort of data. Programmable and automated. I would argue you shouldn't be using any software that you can't install and configure unattended. I guess that rules out BizTalk. So keep doing that, but fix that, because you shouldn't have to ever touch a system to install it. Not nowadays, because you're going to need dev test environments that should spin up based on configuration management configurations. You need to throw this in the cloud, throw up test labs, throw whatever. I should not be clicking next on a window to finish configuring a machine. right? These things have to be installed, configured automatically, and programmatically accessible. You're managing fleets of things now. You're not just managing a box, you're managing maybe tons of things. Programmable, I need APIs nowadays. That's table stakes for most modern systems, especially integration now. Lightweight, so I mean, looking at microservices, look at what even Azure's doing with so many of these services. You're going with hyper-specific things. Event Hubs does one thing really well. Notification hubs, mobile services, app services, they're not trying to boil the ocean with one service. They're doing lightweight, single-focused microservices, if you will. So many of these things are huge. I don't need these giant systems. I need composable systems, not monolithic things. Transient endpoints that you just might not know who your subscribers are. That may be blasphemy, in the BizTalk Zenport world, where I need to register everybody and know what they're doing. But in reality, nowadays, so many endpoints in an integration environment are attaching for a short period of time, or a team somewhere else is attaching to the stream and taking data on. There's no central team managing all that. Here's the data. People come and get it and party on it as they see fit. I'm not having a central configuration. So I have these sort of transient endpoints, which really changes how you think about integration. Low barrier to entry. This stuff should not require a 4-week course to learn how to use it. It's got to be things that's democratized. You heard this yesterday with Logic Apps and Flow and things like that. Is how are we making these things much, much more low barrier to entry, where any engineer should be able to use these integration technologies, not just an integration team, but everybody is doing integration now. It's never been more important. You see all sorts of engineers, full stack engineers, whatever the heck that means, doing everything from bare metal up to the app server. That includes integration. This is not a domain for one team anymore. So what would I argue that you leave behind in this? So what things don't you have in your integration solutions? Not saying these aren't important, just saying that in general, this isn't part of a lightweight messaging solution. So application adapters. Now you saw the discussion earlier, dumb pipes, smart endpoints. The trickiest part with this new world is that many of these messaging solutions don't have a lot of this really cool, but tools that kind of let you get a little lazy, because I can do great orchestration and mapping and all these things that my systems can keep being lazy and dumb. Instead, it flips the paradigm and says my messaging engine has to be great, and my systems have to get a little smarter. They have to handle retries. They should transform their data. They should understand security brokerage. That's table stakes now. I can't rely on all these dumb endpoints and a smart bus. So you get rid of application adapters in some cases. You just have systems that can read from the stream using SDKs, using HTTP, things like that. I might not need a transformation engine. We heard earlier, most modern systems aren't looking at the data anymore. They don't peek at your data. They look at the headers, they may see what's coming in, but they are not inspecting the message. So if you need to transform data, you do that at the edge, where you take it in or where your system pulls from the stream and does something with it. Workflow, that goes somewhere else in a modern messaging system. Not that it's not important, it's just not necessarily baked into what you're doing with core messaging. That sits outside. That's not what you see in almost any of these modern engines now. We all love a user interface. I'm trying to get better at the command line because we keep going back to our roots and loving command lines. There's not as much just core focus on UI. Now I say that, and Saravana does a fantastic job with user interfaces because you need that sometimes. But a lot of administrators and devs want to jump down into the command line and batch things up and script things out, and that's going to be the first thing that most of these products have, and maybe they'll layer on a UI later. Then finally, there shouldn't be integration teams anymore. I didn't mean to put any of you out of a job, but the idea of a central integration team, that's a silo that can't exist in DevOps. It can't exist in Agile. It can't exist in a modern enterprise in the years ahead. It's not going to change tomorrow. But I don't want an integration center of excellence. I want really smart integration people who train the rest of my people to be good integration folks. It should not be a single discipline within a company because you're bottlenecking the rest of your company. So the key is everybody should be good at integration. Some of you will be exceptional at it, and that's fine. Just like in any DevOps team, there's disciplines of people who are smart at stuff. But this shouldn't be just the realm of the wizards of integration. That's not good enough anymore. Wizards of Integration is my new blog. So reviewing some popular things, let's talk about Kafka. So Kafka is crazy hot right now as a technology. For each one of these, I'm going to do three things. I'm going to talk about kind of what's the core definition, what the heck should you know about it, and then how does it work? And then I'll demo it and hope it works. So what is Kafka? So the definition they give you, it's a distributed partition replicated log service. It's like a messaging system, but it actually does some pretty cool things that we'll talk about. If this came out of LinkedIn, they open sourced this in 2011. This was what they used for transmitting hundreds of millions of data points. I think it's well over billions a day now that they pass through Kafka. And so they open sourced this. A huge ecosystem has continued to build around this. It does a binary protocol over TCP, tons of SDKs, .NET, Node, Ruby, REST, PHP, all kinds of SDKs to interface with Kafka itself. It's got basic pub sub, some queuing. So I can group things together and do some queuing. Mainly, it's a pub sub engine. It's pump data in, and it fans it out all over the place. What's fairly unique about it is that unlike most brokers are not designed to store data, right? They're meant to be a transient point where the data goes on and it clears it out. So if I quick ask the question of, I just want to know, I want to see a show of hands of who in a production system has had more than 10,000 suspended messages at one time. Okay, 100,000? 500,000. Is there any hands still up? 250,000. I'm going back down. I want to know the biggest. 200,000. Do I hear 150? Nothing. You're all capped at 100? All right. Who raised their hand at 100? A couple of you? All right. Well, fellow in the front gets a free Pluralsight 1-year subscription because you need more training to get out of doing that poor, terrible environment you have. Come on. It's the walk of shame. You know, you're going out after a late night. There you go. So unlike those horrific scenarios where you're storing that kind of data, something like Kafka is meant to do that. It's meant to be good at storing data. And where it's really unique, and I'll show you how this works, is it stores data in a committed log, and people come and pull on it as they see fit. Now, the system expires it at whatever interval you say, but it's meant to store data, and people go and suck it in. So it's very different from a traditional broker that routes messages to this endpoint or this endpoint. Data's here, you come and get it. What's neat, though, is it targets real-time and batch. So plenty of people use this for real-time data processing. We used it at CenturyLink. Plenty of customers, tons of customers use Kafka. But what's neat is you can use this for batch, too. I could say every night, go pull this much data to happen during the day and suck it all in. And so it's kind of a neat tool that I can do a lot of data processing for things like Hadoop or throw it in a data warehouse, or I could actually party on it in a real-time fashion. So how does it work real quick? So you have a broker. Actually, you have a couple brokers. And these are the things that store some of the messages. It's all wrapped up by a technology called Zookeeper, which does some monitoring of those servers and make sure things are online, maintains a heartbeat. What's cool, though, is you have an idea of a topic. All right. And I can partition a topic. A partition is really the unit of parallelism. When I have multiple partitions, the data is stored in that partition. And as the consumer and the publisher and subscriber, I have to know which partition I'm targeting. So again, smart endpoints, right? I have to know I'm hitting partition 1. I want to hit partition 1. I'm a consumer. I pull from partition 1. It gives me great parallelized performance. Now you might say, well, now I've got some risk because my data, I could lose data. But what's pretty cool is that there's also this idea of replication of each partition. And so you have these sort of followers and leaders. And so each one of those different topic partitions gets replicated around the clusters, and you have some really great high availability in a Kafka environment because of that. Then you've got publishers that dump tons of data into that, which is great at whatever pace they want. Kafka really prioritizes getting data in. We know BizTalk handles this with throttling and other stuff as well, but a lot of brokers start to struggle when you absolutely abuse it with inbound data. Kafka is designed to handle that abuse. You've got consumers. Now what's interesting is the only thing that Kafka knows about the consumer is their offset. This means this is the last thing they read in the log. They store an integer. That's what they know about each subscriber. I don't have a queue for them. I'm not storing data. You're at this position. And then you come back and, next time you pull it, you increment your position. A really interesting model, but makes the engine so lightweight, and that's why throughput is so crazy in Kafka, because it doesn't have to think much. It's not acknowledging a whole lot of stuff. It's not storing a lot of data when people pull data. I'm storing an integer for every subscriber. That's it. So it makes Kafka very high performing. Let's screw around with Kafka. All right, so what I want to do is stuff in the command line. And I am using Vagrant. And let's see, so what I want to do, I'm going to spin up this VM. And so what this box has on is Vagrant, Zookeeper, things like that. And so what I want to do is go into my box, start up Kafka, and I'm just going to publish some messages, show you a user interface. It doesn't come with Kafka. Actually, Yahoo made a really nice Kafka manager interface because they depend on it a lot. And so we'll go check that out. And what I'm going to do is send some messages in, let you see how that works. Kent, how is the font? I've made fun of everyone with tiny fonts today and told them he could yell at me. It's OK? OK, good. So let's jump in the box. I'll go ahead and start Kafka up. And what do I want to do? I built a script because it's weird to start it. Good. And let's go ahead and start the little user interface as well. Right, we'll start the UI. And then we'll jump into the interface, and I'll show you when I create a topic how this works, and I'll actually call it, send some stuff in. You get a sense of what's going on there. So here's the user interface that Yahoo made, which is very nice. It's delightful. So I can look at an interface. I can see clusters. I can see brokers. I can see topics. I can see who the consumers are, things like that. Nothing rocket science, but I have one dumb topic in here for employee records. Let's create a new one. Let's call it not Seroter stats. That's odd. Server stats. And you can see how many partitions do I want? How much replication do I want of the given topic? So then I can mess around with this stuff after the fact as well. Let's create that. So I've got a topic now. So now I want to publish to this topic, and I want to read from this topic. So at least throw out some love to Microsoft. I'm using Visual Studio Code. And so let's go ahead and make sure I'm in the right one. That's not the right one yet. There we go, Kafka. So I'm going to publish. I'm just going to throw some telemetry data, completely fake telemetry data, whatever. I'm just throwing something in there. I want to show how that goes in. I send that in. I say which topic I'm targeting, and I'm just a JSON encoded message, going to send it in 50 times. This first demo doesn't work. I'm in bad shape. All right. So I want to do node, and I want to do, I don't remember the name of my file. Now let's go into demo 1. So let's go ahead and kick up my Node app and just publish messages to Kafka. All right, so I sent in 50 messages. That's exciting. So let's go ahead and see what that looks like. If I look at my topic, or I look at my broker rather, I can see for this broker, data should be coming in here in a second, or it'll show it. It's already there. It's just the UI is taking a few seconds to refresh. But there's no consumers for this right now, but that doesn't matter. It'll just sit there. Now, you might have this by default. It expires the data every day. At CenturyLink, we kill it every 5 minutes because it was so much data. I didn't need to keep it for so long. But you can keep it for whatever time you configure. All right, some data came in. I don't have any consumers yet. So let's go ahead and start up a consumer in this window. All right, he pulled 49. Good for him. If I look over here, I can see I've got a different consumer. It's still pulling in some information, but what it stores is the lag. So it knows I just pulled the 50th one, right? And then if I send in more data, it's going to be behind by 50, whatever. It's keeping track of, that's the only thing it knows about the consumer is what was the last thing it read. Other than that, it doesn't know anything else. This thing should be all caught up. Yep, no lag. So that's interesting, but let's see that example I mentioned that is about replaying. So what happens when I want to go back and say, shoot, my endpoint was down, it's the end of the day, I want to synchronize my stuff, I want to go replay from something else. So what Kafka lets you do is, let me go into demo 2. And what I can do is if I look at that in Visual Studio Code and jump into this publisher, on the consumer I can say, go ahead and pick a specific offset. And if I know that my last time I read it was position 40, shoot, now there's 50 things in there. I want to go read back the last 10. Again, that's a really nice pattern. And systems that are that durable and let you replay, that's a pretty powerful idea. So if I just come back into my consumer and run this, it should only pull back the last 10. If I go back and look at this, sure enough, it started at 40. So kind of a nice way to be able to see, here's a log. I just want to go pull data with whatever sees fit for me. It's a nice pattern to be able to do. It's convenient when you've got these very high volume systems and you might have some transient endpoints that need to kind of come in later on and pull data.
So now I can create a second customer and that can also read from 0?
Right. The question is, can I create a second customer and they come in and party at 0? Yeah, the idea is anybody comes in and they pick the point in the stream and they start reading it in, assuming the data's there, right? If I'm purging this data every 10 minutes, I can only go back 10 minutes. If I'm keeping it for a day, anybody can come in at any time and suck onto the stream.
So the message itself has something like a time to live?
The data in a queue, data in a topic has a time to live. Exactly. All right. First demo working, that's good. Thank you, Saravana, for blessing the demo gods. So that's Kafka. Kafka's pretty awesome. Again, a lot of publicity about this right now. And so let's talk now about RabbitMQ. Now, Pivotal is actually the lead maintainer of RabbitMQ. We're also the lead maintainer of Java Spring and Tomcat Server and other stuff like that. So I'm mildly biased, but I've only been there a month, so I'm not that biased yet. But we do a lot with RabbitMQ. And so what is that? So Clemens touched on some of the related things this morning, but if we look at the definition, it's a messaging broker. This is going to be more familiar to you in a traditional messaging sense. It's got topics, it's got queues, it's got a persistent engine, all those sort of things. It's for pub sub routing. This is kind of what RabbitMQ is good at. It's been around for years. So what should you know about this thing? So it does implement the AMQP. I'm not going to go into the level 900 depth of Clemens on AMQP, but this actually doesn't use AMQP 1. It uses AMQP 9.1, which is really a fundamentally different flavor. We haven't decided if we want to up to that yet. You can have a plugin that ups you to that. But what it gives you is a cool way to have cross-platform communication between endpoints. Is that this sort of thing, RabbitMQ runs on Windows, runs on Linux, so does Kafka, so do all these. But it gives you a nice way to have tools that can talk to each other even if they're not actually the same platform. What's nice is it's fairly pluggable. It's a fairly lightweight installation. It's a fairly lightweight engine, but I can plug in things like MQTT if I'm doing things around Internet of Things. I can do some nice things with plugging on monitoring tools and maintenance, and even an AMQP 1.0 adapter is something that's just plugged in. So it's got a nice ecosystem, a nice model for that. What's pretty interesting is that you can persist data either in memory only or in memory and on disk. So I remember MVP summits from, 2010, where we're begging for, can we have a choice to not use the message box and just have it in memory for low latency? And we're dreaming of an in-memory option for more transient data. Alas, that never happened. But RabbitMQ supports that model, where I can say, look, this sort of data coming through, I want it to be a little more performant. It's OK if I happen to lose data. I just want it all in memory only. I don't want to pay the penalty of writing to disk. So that's kind of a cool option you can have there. Supports a handful of routing strategies. I can route based on headers. I can route based on a topic. I can do fan outs where everybody gets it. So some nice ways to do more complex routing scenarios. Things like Kafka are very simplistic in their routing. If I need something that's a little more sophisticated, Rabbit does a nice job of that. It's got a pretty mature ecosystem. It's got a very attractive set of committers, of course, but it's got a number of things of community tools. It's been around for years, started out in the financial services industry. It's a pretty rock solid tool. Whereas Kafka is doing millions of messages per second, we've gotten RabbitMQ up to a little over 1 million messages a second a couple years ago. So you get a great volume in it if you'd like to. It's not for the crazy throughput you're probably going to have with something like Kafka. So how does it work in a nutshell? Well, you have a node, probably multiple nodes. It supports clustering if you're trying to do higher performance, so you can actually shard some of the information. It also supports mirroring, so you can do HA and have data mirrored across the various nodes as well. It's still kind of a master-slave model, so you're not getting parallelism out of that. But it gives you a couple of different tools to spread out load and spread out your data. You throw on your topics on there, your queues, rather. What's interesting is that, and Clemens touched on this a bit with the model, but you've got exchanges, which really are a level of indirection between a consumer and the queue. The consumer never publishes to a queue. They publish to an exchange, and that exchange is bound to a queue based on a definition of how you want to route to that queue. Gives you a little bit of indirection that can be valuable when you're trying to version things on each end, and I don't need to necessarily change anything just because I changed the routing in the middle or things like that. So it gives you a little bit of indirection between the two. And then publishers and consumers pumping their data into here. So let's see a quick.
Exchange and broker is very similar to a topic if we were comparing with service bus.
So the question is an exchange broker kind of similar to a topic. So the exchange kind of, when you bind that and you choose the sort of exchange you choose, is it a topic? Is it a kind of a one-to-one queue? Is it whatever? Everything ends up into a queue at the end of the day. The exchange defines that messaging pattern into the queue. All right, demonstration time. So let's look at Rabbit next. All right, thank goodness for Vagrant. If you haven't used this already, it's a great front end to virtual machines. All right, so I'll spin up my Rabbit box. I'll just do a couple of demos, show you the idea of the sort of topic broadcast, and then I'll also show you one with more wildcard routing as well. All right, so that's spun up. Let's go ahead and jump to my Rabbit examples. Hopefully this is also now online. Good. So this actually does come with RabbitMQ. It's not a third-party add-in. It's stuff that the part of the open source product. All these are showing you, of course, are open source, so they are free. You know, Service Bus for Windows. Hopefully they'll have a good price point as well. Just messing with Clemens. So if we look at this, how do I want to set this up? So let me go ahead and set up an exchange. Right now I have nothing but the built-in ones. These are just the built-in exchanges that come with that. I might want to start with a queue first, though. So let's go ahead and create a couple of queues. Let's give it a name first, so I don't have an empty queue. We'll call this one Notes 1. Let's say we were routing messages based on notes from the Integrate Summit. Integrate conference makes tons of sense. Don't judge me. You can make these durable or transient. How long should they live? These are temporary things I'm attaching, and as soon as I detach from this, it should go away or not. You can define some of these things. So I'll have Notes 1 and Notes 2. I want to be able to route things to this and see it go there. If I go to an exchange, this is where I would actually say, how do I publish to these things? So I'm going to go ahead and create a brand new exchange. Call it Integrate Notes. And I have choices, as I mentioned. Those are small. Let's make that less small. So I can make it fan out, which just sends it to every subscriber. Doesn't matter. Everybody who's bound to this exchange, doesn't matter if they had a specific routing key or not. Headers, topic, things like that. But as Clemens and Dan mentioned earlier, again, this idea of not inspecting the message. I'm never inspecting the message as part of this routing. So let's say for this one, I go ahead and pick a fan out one so everybody gets it. We'll go ahead and add that. For this one, I can go in and then bind it to a particular queue. So I'm going to bind this to Notes 1. Because it's a fan out, it's not even going to look at this routing key, so I'm not going to bind anything. Think of this as just kind of, again, a unique routing identifier that you could target things at. I'm not going to do that. I'm also going to route it to Notes 2 because I want both of them to get it. All right, so that's all I technically need to set up a routing. So if I look at my code and I jump into demo 2, I'm just sending it to an exchange called Integrate Notes. I have no idea what queues are behind this. I don't care, frankly. I might be adding queues, removing queues, doesn't matter. I'm sending to an exchange. We're publishing some notes. Hey, I'm doing open source messaging. I'm showing off RabbitMQ. It's very meta, but I'm trying to show a concept here. And I'm going to have two receivers. This one's receiving a queue for Note 1, and this one's receiving a queue for Note 2. So again, not rocket science, but showing that I'm able to route to both. So if I come into here, and let's go ahead and route here. So I want to go into my Rabbit one. And let's go ahead and node, let's send those messages in. All right, so it sent a message in. If I came back into the console, I would expect to see I've got some things queued up. Here, I've got two messages, they're ready. So there's things sitting in there. It's a regular pub sub engine, right? It's durable messaging. When things come online, it'll go ahead and receive its message. So let's go ahead and do that. So let's go ahead and not do it in this folder. All right, so let's go ahead and start the first one. Let's go ahead and not do that. Oh, there it is. All right, so it received it. It worked. So that first one received it, no problem. I could also do the same thing from receive 1. This should be less interesting, but it also received it, nope. Did I get Notes 1 and Notes 2? Oh, I did the same thing twice. Demos don't work if you do them wrong. Hey, received 2. All right, and it should disappear from the UI here as well. So a very simple pub sub in this case, but let's do something a tad more sophisticated. So let's jump into an exchange and say, all right, well, I want to do something that actually routes based on a particular key. So in this case, let's go ahead and say I want to do integrate notes routing. And I want to do, let's say somebody's live tweeting this, and they're sending out recaps, they're sending out links, things like that, and I want to just subscribe based on that. So I want to do a topic. So for this one, I want to go ahead and do a topic. Let's go ahead and add the exchange. All right, so for this one, I'm going to use those same cues, because why not? This one, I'm going to say I want links. Anytime someone posts to this exchange and they do links, but you know what, maybe I also want the recap to see what's going on there. But you know, the other cue, man, I really just want links, because I'm just going to follow stuff later. I could set things up like this. So I could have things going to different places based on which message was coming in. What that looks like in the code, if I look at demo 3, is I'm going to send this in, but you can see now I'm giving it a routing key. I'm saying route this to links. This is of type links. So if anybody has this routing key, they should go ahead and pull that in. What you'll notice, though, is that these listeners have no idea of that again, right? That linkage is in the exchange, not anything in the queue definition. So you're just separating things, making it a little easier to maintain these sorts of things. So if I come back into here, jump into demo 3, and I send that in, both of these, I think, are receiving links at the moment, if I look at what I'm sending again. So I would expect both of these to get these. Yeah, I was already listening. All right. See, I'm getting notes. It's a life-changing content.
So who is the speaker with it? That's very deceptive.
I am deceptively handsome. Don't judge me. So if we go into, now I'm distracted. So if we come back in, what I'm seeing is both of these should get this message, right? They've both subscribed on it and been able to get that in. If I happen to change this and only sent this to recap, then only one would get it. So the idea of being able to route based on headers, route on routing keys, just gives you a little more focus instead of doing something like Kafka, which is more of just a quick broadcast out. Awesome. So the third one that I want to focus on with you is called NATS. And maybe you haven't heard of NATS. NATS is pretty neat stuff. So this is also open source. It's described as and I like the definition, kind of the central nervous system. So it's a kind of a different sort of messaging engine, which we'll talk about in a second. Extremely, extremely high performing, comically lightweight, and something that is really, over everything, is focused to stay online and make sure that it's able to process messages. It offers up some different patterns you might not try to do in a traditional messaging engine. So what should you know? Extremely lightweight. It was originally written in Ruby, where they would get about 150,000 messages per second. They rewrote it in Go, and now they get 11 million messages per second. So they're not messing around. When I say lightweight, though, it is a 3 megabyte Docker image size. Like, it is comically small. I think the BizTalk dependencies are 4 gigs. So to get into, like, the whole thing is tiny. And being able to run this, what that means besides making jokes is I could stick this on the edge, right? I could have this on devices. I could have this in other places, and I could do some pre-filtering based on a very, very lightweight, high-performing messaging engine. Again, text protocol over TCP, lots of SDKs, .NET, Java, Haskell, Node, Go. A lot of different ways you can pub sub into NATS, which makes it really convenient. Does straight up pub sub, does some queue-like things that people can subscribe to the same thing, so therefore it creates a queue out of that communication. But by definition, everything's just pub sub through the engine, which helps it be extremely high performing as well. But as I mentioned, it's extremely aggressive in terms of how it operates. It doesn't persist any data to disk. So this is truly, again, nervous system. It's communications. It's not, I'm storing business critical data and I'm going to bounce boxes and it's still going to be there. It's not what this is for. It's for routing data that might be telemetry data. It could be lookup data. It could be heartbeats for different services. It's meant for that sort of messaging. But it even does some pretty aggressive things. It says, look, I'm going to ping all the clients every so often, and if they're offline, I'm taking them off of their subscription. So it purposely prioritizes availability, trying to make sure that no one does things they shouldn't. It makes sure that responsible listeners, back to the point, I need dumb pipes and really smart endpoints. That I can't have endpoints that are just kind of out there. They have to be available. They have to be built to be available and respond to things like this. How does it work? It's really simple. I mean, NAT servers, I couldn't even create an architecture diagram. Very, very simple stuff. It runs super fast as an engine. You publish data into it, whatever pace you want. And then consumers have to be online. If a consumer is not online, they will never get that message. And if you're, that's the easiest way to think about it, is you're online, you get data. If you're not, you're not. And that's going to be great for certain things. You're probably not putting patient data through that in a healthcare scenario. I get that. Are you putting heartbeat data for your services? Heck yes, because if I miss one, who cares, right? Not all data needs to be persisted, and we need to make sure we help enterprises and our customers think of data differently, that there are types of data in different places that need resiliency. In some cases, speed matters. So I'll do a quick demo here and show you some of the performance and even some of the pub sub-scenarios you might do with this. So I'll spin that machine up. Let's make sure these guys aren't running. Good. If we look at the code for here, again, it's very, very simple stuff. Not Kafka. There we go. Let's go to Nats. And for the first one, I'm going to publish 6 million messages in. And I would do more, but I keep breaking my laptop because I'm doing horrible. I mean, this is the worst performance testing code you can write. Therefore, that's why I don't get paid to write code anymore. I'm just doing a loop in Node. It's not the right language to perf test this in. You could do this different ways with recursion. That's not the point of it. The point is to try to beat the daylights out of an app. So I'm just going to run through this. I'm actually going to spin up 2 instances of this. And we can see I'm just going to pump in 6 million messages, and let's see what happens. First, I have to make sure Nats is running. Not you. Get out of there. All right, so Nats is up. Let's go ahead and get into the box. And I'm going to do a couple of things here. So I'm going to go run Nats D. I'm going to make sure the monitoring port's open, and I'm going to throw it in the background. And then there's a tool that's in the ecosystem, Nats Top, which shows me my messages per second, shows me my CPU load, all this kind of stuff. So it lets me see some basic health of what I'm doing here. So let's go ahead and jump into that project and see what I can do to this thing. Let's find where I'm going. All right, let's get into demo 1. And what I'm going to do, let me go create a second one of these so that I can actually run it twice. And I'm going to do node, what did I call this thing? Node publisher. And actually I have to do something funky because I kept breaking Node.js. I need to tell it to use all the memory on my box because it stops at 2 megs. So I need the max old space size. So I'm telling it to use 4 gigs of memory on my machine when it runs this. All right, and let me get this one queued up. So I'm going to run both of these bad boys at the same time. What's this thing called? Old space size. Have both of these guys eat up 4 gigs and publisher. All right, the problem with Nats is things run too fast, and so it makes it hard to do demos. But let's go ahead and, what did I call that one? Max old space size. Oops. Equals. This is why user interfaces are delightful. All right, so let's kick that guy up. He's starting to run and make 4 decisions. This guy's running. And so what we'll see is messages per second. I'll kick up in a second once Node.js queues up 6 million things. And so it's starting to process quietly. OK, it's doing 12,000. Doing a couple thousand as it warms up. Now we're doing 100,000. Now we're doing 600,000, 1,000,007, 1,000,076. And this is, and I'm at 4% CPU. So what the what? Like that's amazing stuff, and it's done. Like that was I don't know how long it would take me to run 12 million messages in most systems. It's typically not that fast. And I'm not even stressing this thing. It does 11 million if you were testing this with Go and other languages. They're better at threading and perf testing. So that's ridiculous. But that's awesome, right? I want to have systems that I could pump that kind of data into and see that process that quickly from a developer laptop. But there's other scenarios that make sense. So most of these things, Rabbit does this too, is it does support a request-reply pattern as well. So what if I wanted to do request-reply with something like this? What might the scenario be? So one scenario could be, let's jump in and say, what if I wanted services to tell my caller if I was online? Really poor man's service discovery. Right, you see this more and more now where my endpoint isn't fixed. I actually go ask a service to say, where is my database service? Where is my whatever service? And it goes back and gives me a URL, because things are very dynamic in a microservices world. So in this case, what happens if I wanted Nats to do that? So it's acting like my central nervous system saying, go ahead and just give me the endpoints that are online. So if I wanted to do that, let me go ahead and start the services that I want to run. And then what I want to do is have Nats query into that. All right, so I'm going to start up responder. Actually, let's create a second one of these so I can do this twice. So I'm going to start up responder.js. Nope, I got to start node. And I've got to, am I calling it wrong? I can't spell. All right, third time's a charm. And let's, on the second one, start it up. So now both of these services are waiting to respond. I don't remember what I called the second one. OK, so they're both up. These are just web services that I have running. And so the idea is if I look at my code, how would this work? So if I look at that, responder is listening on Nats, right? It's listening for messages saying, here I am, and here's my endpoint, right? So these services could have an endpoint that listens on this at all times and responds to it. My requester is calling a request operation, and it's going to get back something from the endpoints. So it's just throwing something out there to the message bus. I'm not binding to anything. I'm not looking up. I'm letting the message bus do the work for me. So if I come into that and call it, I should be able to say node requester, and I got them both back because I'm not queuing them right now. So right now I had both services respond, and they both told me they're online at a certain place. I used the message bus to do that. I didn't have to go look up in some other place. The message bus was actually telling me services were online. What if I didn't want that to happen? What if instead I wanted those services to queue, so only one of them responds? I could do that. So if I come back in here and just quickly make a change, what I can do in both of my responders is I can create a queue group out of this, if I could spell queue. And this might just be availability. And so let's say I want to create this. And so that means I'm creating a queue out of these endpoints, and only one of them will get it. Now what's nice is because services only respond if they're online, I don't have to worry about an offline service returning back or something weird happening there. All right, I'm apparently deficient at copy and pasting. It's been a month. I haven't learned how to use a Mac yet. All right, so I'll put that in there. All right, so what should happen now when I start these services up is that only one of them should respond. And it's going to be random based on Nats just routing things randomly. So now when I call, I should just get one back. Sure, so service 2 is online. For some reason, it does the same one for a while before it flips, but I guess that is the definition of random. So it's just returning 1, right? So by definition, it's doing a random. It's not even round robin, just a random routing. So you saw some crazy performance stuff, but also maybe some interesting patterns from how do I use a messaging engine to actually help me do lookup information? How do I decouple my services and never have one service directly binding to another potentially, but use the message bus to actually communicate health and availability and what services are out there, really broadcasting availability, things like that. So if I were making some lightweight comparisons to the Microsoft portfolio, question from the front.
Is it actually waiting for the subscriber, or does it have an index of how many of the subscribers?
Question is it waiting for a subscriber? Does it have an index? It maintains a pretty dynamic subscriber list, so when someone attaches, it knows about it. If they're offline, then they don't exist. So they're.
It's kind of a heartbeat kind of thing.
It's a.
So the subscriber is giving a heartbeat saying I'm still around.
Right, subscriber has to be online, and they always have to respond to a heartbeat in order for Nats to send something there. So if we take a quick look, if you're looking in the Microsoft world going, all right, how do I compare these? Kafka is kind of like Azure Event Hubs. There's going to be some differences, but why are they the same or why are they similar? If you read the documentation, you could have a little deja vu, because it writes in a very similar sense. If I've got a partition log, I'm reading things at offsets. So it's a well-described model that Event Hubs also follows there. And also, Event Hubs is not meant to be your ESP. It's prioritizing velocity and intake and prioritizing that data processing. It's not prioritizing all the other things that typically come with a big, heavy ESP. But very different protocol support. You've got AMQP versus that's not in Kafka. Different hosting options. There's no Kafka as a service per se. There's also not yet Event Hubs on premises. So there's different sort of models you might run here. All the things I just showed you, Nats added Windows support 2 days ago, Kafka, RabbitMQ. They all run on Windows and Linux. They run on-prem. They can run in the cloud. There's going to be some differences there than the pure play as a service in Azure. RabbitMQ is kind of like Azure Service Bus, topics and queues, right? You saw some similarities there. How I want to do some routing, AMQP support, different versions, but nonetheless, they're in the family. They're related. Similar pub sub constructs, how they're routing information back and forth, how you have things routing. It's similar. They're not inspecting the message, but different. Different hosting options, again, where it runs. Different durability choices. Am I running in memory? Am I running on disk? But it's, at least, again, a similar mental model between the two. I have no idea what the hell's like Nats. I don't think there is one, because it's a fairly unique thing. Why? Well, because the portability is crazy by its size and what it does. The performance story is fairly unique from being able to do something like this. And the key of being able to play that cool one-way, two-way thing, being able to do request reply or do pure play, just publish stuff in there, is fairly cool and unique. You might find some neat examples for this where this would sit next to a BizTalk environment. Many of these things are going to be complementary. Very few of these things would you say, I'm going to replace BizTalk with Nats. That is, you should be committed. Like, there's no mapping there. They're very different products. Now, if you were abusing BizTalk in scenarios to do high-performance computing stuff, all right, maybe those should run in Nats. But these are very side-by-side complementary options. These are not either or. These are and. And so for a lot of these, you're going to see a lot of these coming into your customers or yourself if you're coming here as a client of these tools. You're going to see your CIO asking about them. You're going to see your technology dev guys playing with this. It's fun to know what's out there. So I flew through three things. I wanted to make sure we looked at those modern criteria because things are changing. Maybe slowly, maybe in some industries faster than others, but make no mistake, microservices, DevOps, IT budgets being spent outside of IT, those are changing the nature of where your apps run and how you connect them. So you have to think about integration a little bit differently. Lots of open source stuff. I didn't even talk about ZeroMQ. Didn't even talk about tons of other things that are out there. A very dynamic space. It's never been more fun to be an integration person. So I just raise your gaze a little bit sometimes and look at the landscape because everybody's doing crazy stuff. So pay attention to that. But Microsoft, candidly, this is the first time in 5 years I've been excited about what Microsoft's doing in integration. Like, the last 2 days have been fantastic, and the team is doing a remarkable job. And so many of these things have great parallels. I came in here ready to say you're only getting innovation out of open source, and I can't say that now. So you're getting a lot of innovation from Microsoft here. Map some of these concepts to there. If you're a Microsoft shop, just look at some of these patterns and see if maybe they can be more applicable to you. Thank you, thank you.